Hey!
I think I need to bother you again. I want to use sodium metal in my next reaction, and I was wondering if you could show me how to use it.
Sure, I can help you out. Since you've already learned how to use pyrophoric liquids, we're going to use similar safety measures for reactive metals.
So we need to use the Nomax lab coats?
Yep, and we need to use a special fire extinguisher because reactive metals burn at a higher temperature than organics.
I'll go get the sodium and the protective gear. I'll be right back. Here, I got the sodium.
Okay. And I have 3 beakers prepared, 2 with hexanes and 1 with butanol. The sodium is stored in mineral oil to protect it from air. So first we take a chunk of sodium and wash off the oil with hexanes. You can see that the surface of the sodium is covered with an oxidized layer that we need to remove. Since sodium is soft, we can cut this layer with a scalpel. To clean up the surface, we will place this piece in butanol. Butanol reacts slowly with sodium, and this exposes the surface of the metal. When the surface is shiny, we can transfer the clean piece into the other beaker of hexanes, and there it will be protected from the atmosphere and ready for use.
So how do we dispose of the solvents? Don't they contain sodium?
Yes, it does. So we're going to need to quench it by adding a small amount of ethanol until we don't see any more bubbles forming. Now let me show you why we're taking these safety precautions. Small pieces of sodium will react with water, while large chunks tend to explode. And remember, potassium is even more reactive than sodium. It's sufficiently exothermic that it will ignite the hydrogen gas that it gives off.
Thanks, Matt. I'm glad I asked you for help.
You're welcome. It's better to have asked for help than to have gotten yourself in trouble not knowing what you're doing.